Hello everyone. Today let us discuss about measurement of mass. In our previous videos, we have seen how to measure length, and also we have seen what are the base quantities, and how to measure the base quantities in SI units. For length, it is meter. For mass, it is kg. For time, it is second. Now, coming to the point, today's topic is measurement of mass. What is mass? Mass is the basic property of matter. It does not depend on the temperature, pressure, or location of the object in space. The SI unit of mass is kilogram. The basic property of the matter is the mass. It is a basic property. Mass will not change if temperature changes. Mass does not change if pressure changes, and it does not change if the location of the object changes. That means if you go from one place to the other place, mass will not change. Now, coming to the point, this mass is measured in kilograms. Suppose when you are going to measure your own weight, there is a weighing machine to measure your weight. And if you want to measure your weight, if you go to a vegetable vendor and ask them to measure your weight, they will laugh at you because that weighing machine weighs only small quantities of vegetables, etc. Therefore, for human beings to measure their weight, there is a different machine. Similarly, to measure a small things like gold ornaments, a finger ring, and earrings, like very small things of very less weight. The gold shop people, jewelers, they have different types of weighing machines. We cannot take vegetables and weigh in that because we cannot measure so many kgs in that small machine. In the same way, we cannot measure very big weights in uh, ordinary machines. So we stay in a colony where one of the topmost steel factories is there. We stay in a colony. That colony belongs to one of the topmost steel factories of India. Every day we see some tons of iron is manufactured and it is sent by goods trains and so many trucks and so many other vehicles. And we see them every day here. To measure the weight of that manufactured steel, there are separate weighing machines. So different weighing machines are there to measure the weight of different things. In the same way, to measure the mass also, we have different methods because mass changes from very low values to very high values. When we are talking about atoms and molecules, the kilogram is an inconvenient unit. Sorry, it is an inconvenient unit. So, kilogram is not a good unit for atoms and molecules. As you know, they are very, very, very small. So, for that, what is the unit? In that case, scientists use one important unit of mass that is called as unified atomic mass unit. Unified atomic mass unit. Unified atomic mass unit. It is given by a small u letter, English alphabet, small u letter. One unified atomic mass unit is equal to 1/12 of the mass of the carbon atom. That is 1/12 of the mass of an atom of carbon 12 isotope, that is C612, including the mass of electrons. That means In simple words, if you take a carbon isotope that is C612 and if you measure its mass, this one unified atomic mass unit is 1/12 of that mass. That is equal to 1.66 into 10 to the power of minus 27 kg. That is equal to 1.66 into 10 to the power of minus 27 kg. Now, mass of commonly available objects can be determined by a common balance like the one used in a grocery shop. As I told you, so common things when we go for so many things to buy like rice and then we buy dal and we buy many other grocery items. Then to measure them, they use one common balance. Very large masses like universe, like planets, stars, to measure them, what can be used? For example, you want to measure the mass of a star, you want to measure the mass of a moon, then how you can measure them? So, to measure them, they use Newton's law of gravitation that is based on gravitational methods. You know Newton's law of gravitation, that is, force between two objects in the universe is directly proportional to product of the masses and inversely proportional to square of the distance between them. That's so we know that F is equal to capital G m1 m2 by r square. Using that Newton's law of gravitation, they can measure the mass of planets, stars, etc. This you will learn in the chapter that is called as gravitation. Newton's law will be clearly explained in that chapter. And coming to the point, now to measure them, that is the mass of planets, stars, and etc., universe, we use Newton's law of gravitation that is based on gravitational methods. So, large masses in the universe based on Newton's law of gravitation can be measured by using gravitational method. Now, for measurement of small masses of atomic, subatomic particles, we make use of mass spectrograph. Small masses like atomic, subatomic particles, we use some methods that is using mass spectrograph. The masses of objects change from 10 to the power of minus 30 kg to 10 to the power of 55 kg. Small masses we told, that is like atoms, electrons, protons. So like that if you take, the electron mass will be of the order of 10 to the power of minus 30 kg. And biggest means the highest mass, that is the biggest thing, is universe. Highest mass is of the universe, that is the biggest thing. That mass will be around 10 to the power of 55 kg. Therefore, then the range of masses is from 10 to the power of minus 30 kg, that is of an electron, to 10 to the power of 55 kg, that is of universe. Thank you for watching this video. We will meet in the next video. How to, we will meet in the next video by learning how to measure the time. Till then, bye. God bless you.